my name is Sarah Turley, and today I'm going to be doing a presentation on the Chem 120 experiment, What's in the Water. So this is just a quick presentation overview. I'll be starting with an introduction of the experiment, followed by experimental procedures and an introduction of some of the scientific tools I used. And then I will analyze my IR and NMR graphs of my unknown, followed by identifying my unknown, and concluding with the unknown's effect on the environment in humans. So I wanted to start off by going over the objective of the experiment, which I got from the lab manual, stating that the objective of this experiment was to identify unknown compounds detected in a drinking water sample supplied by contaminated surface water using spectroscopic techniques. So before getting into the actual experiment, I wanted to do some background info about what is actually in our water. So according to the Do Something Project 2015, each year 1.2 trillion gallons of untreated sewage, stormwater, and industrial waste are dumped into U.S. water. The Do Something 2015 program also states that approximately 40% of our lakes in America are too polluted for fishing, aquatic life, or swimming. So considering where we get our drinking water from, either that be the tap or bottled water, you may ask, how clean is it? So, well, according to Natural Resources Defense Council 2016, our bottled water plants must test for bacteria only once a week, while City Tap needs to be tested more than 100 times a month. So even with the testing, there are ways chemicals can still make their way into our drinking water, especially coming from bottled water, which we believe is some of the cleanest water. So to identify my unknown chemical sample in my water sample, I used two spectroscopic techniques: infrared spectroscopy and nuclear magnetic resonance spectroscopy, IR and NMR for short. So the first machine used was an IR. An IR spectrophotometer helps to identify functional groups present in the compound through corresponding peaks and through known compound values. So the machine I used was a Thermo Scientific IS spectrophotometer, with the computer software connected to the machine being the Omnic software, and I took 16 scans of my unknown. So right here are salt plates where I took drops of my unknown and almost sandwiched the salt plates together and put them in the IR, so that's how we got our scans. This is a table that was filled out prior to the lab, using Lewis dot structures from each compound and documenting their known functional groups as a reference. Using the data on the peaks on this graph, we were able to identify functional groups given information by the lab manual once we get the scans back. So this is the information given by the lab manual. These right here are functional groups. So when I get an IR scan, I'm going to look at, which you'll see later on in the presentation, the numbers that correspond with the peaks, which will go with these functional groups. And kind of an overview, this was a topic covered in lecture. A functional group is a group of elements or compounds responsible for the characteristic of a particular compound. So this is my IR scan for unknown 55.1, and as you can see here, there are two distinct peaks that we focused on. And these other values to the more right of the scan are known as fingerprints or footprints. They're values that aren't as substantial as more of the left spectrum of the data. So my two peaks were 3,339.32, which corresponds with the alcohol or the OH functional group. This information was derived by looking at that table that I showed previously in the slide in the lab manual. And the second peak I got was 2,974.36, which corresponds with the CH or singly bonded carbon functional group. Now, using both of these compounds, I went back to that table that I showed earlier, and I found a list of possible compounds that can be devised by just using both of these functional groups. So those compounds were methanol, ethanol, T-butanol, and 2-propanol. After doing the IR scan, the next form of spectrophotometry used was NMR. An NMR spectrophotometer helps to identify the types of hydrogens present in a compound sample as well as their corresponding ratios. So I'll explain this later in detail when we actually look at my sample. The machine I used was EM360A Varian. So the machine software, meaning which is different from the IR, the software actually inside of this machine used was the PNMR H1 software, and the computer software used was the NUTS program, and unlike the IR, I only took one scan of my sample. So this, just like the IR table, was a table that we devised prior to the lab by looking at Lewis dot structures and looking at different compounds and other things in the Lewis dot structures. This is unknown 55.1's NMR spectrum. As you can see there are 3 distinct peaks, meaning that there's 3 types of hydrogens present in my compound. Also, the peak data states that the first one is 1, the second one is 1.87, and the third one is 2.90, which corresponds to the ratio 1 to 2 to 3. So just like the IR, we're going to look at the previous table and the found data from the NMR, and 2 compounds have been identified with the same number of different types of hydrogens and the same exact ratio, being ethanol and ethylformate. Now to find my unknown compound, both results of both scans were compared. So looking at the overall compound, they must both have OH and CH functional groups and 3 types of hydrogens with the ratio 1 to 2 to 3. So from looking at those 2 options of lists, my unknown value was ethanol. And now that we know the unknown, let's double check real quick with both of the scans. So here we see our alcohol functional group, and we can see that our CH functional group is also present in the compound. Next is the IR. So this gives you a better look at what I meant by the different types of hydrogens. So this first group of hydrogens is 3 hydrogens attached to a carbon, which is also attached to another carbon, making them their own group of a different hydrogen. The second group is 2 hydrogens bonded to 1 carbon, which is bonded to a carbon and another OH. This last group is just a simple hydrogen bonded to an O, bonded to 2 carbons. So this is leaving us with 3 types of hydrogens. Secondly, you can see that there are 3 types of the first hydrogen, 2 types of the second hydrogen, and 1 type of the third hydrogen, leaving us with the ratio 1 to 2 to 3. Now what really is ethanol in our world? Well, according to the US EIA, ethanol is most commonly found in the environment as an alcohol made from biomass materials like corn, sugar, etc. The US EIA also states that the most common use for ethanol when mixed is in most gasolines we use today. So this is a funny comic I found that says, no matter what I produce, it seems to cause a drinking problem. Ethanol is used in common alcoholic beverages in production of fermentation, and also used, as I said, in gas, which can, as I'm going to explain, affect our water in many different ways, thereby showing the water tower. So the U.S. Energy Information Administration 2017 states that common ethanol gasoline can be used in motor vehicles everywhere and transferred into air pollution. This pollution is created and can easily find its way into our water sources. Additionally, ethanol mixes with high evaporative emissions, which contribute to smog and ozone, which we know is very bad for our environment. So this is a little extra research I found. Biomass fuels are said to be one of the better forms of fuels besides electricity and electric cars for our automobile usage. But from this research from the Union of Concerned Scientists 2016, it shows that all of this ethanol biofuel is still responsible for 3 to 5 metric tons of CO2 production per year, which contributes to our ozone. So even though, yes, it isn't as bad as pure gasoline, which comes out around 6 metric tons of CO2 per year, it's still on that upper half spectrum. Now what happens when ethanol gets in our water? Should we be warned about it? Well, according to the U.S. Environmental Protection Agency, ethanol is a compound precursor to a larger compound called acetaldehyde. High acetaldehyde formations can result in serious health effects like respiratory inhalation and irritation, especially when it comes from that smoke, that smog coming from cars. Especially when the chemical is in high concentrations in water and is ingested, it can cause a lot of GI tract issues. But the water that we're drinking, since it is tested, even though bottled water is tested once a week and tap water is tested over 100 times a month, we shouldn't be that worried because the concentrations that we are finding ethanol in our water are so low that they wouldn't really affect our bodies unless some accident happened to where the concentrations would be increased. So overall, there is not really a worry, but it's nice to know what's actually in our water. This was my presentation. Thank you for listening, and here are my references.